angle addition postulate. Okay, so this time instead of looking at a segment, we're going to be looking at an angle. Now, before we try this proof down here, let's go back up and actually look at what the postulate says. So I'm going to draw a picture. I'm going to start with a large or larger angle. I'm going to put a point here. I'm going to put a vertex here. I'm going to put a point here. And then from my vertex, I'm going to kind of come out and create two other angles inside my bigger angle. Now, just for the sake of argument, we're going to label this A, B, C, and then D. Now, what the angle addition postulate says is that the measure of angle A, B, D. Okay, when you do an angle, you start at one end, then you hit the vertex, then you hit the other end. So A, B, D. You should be able to trace it, okay? When you name an angle, the vertex is always in the middle, and you always need 3 letters. If you don't give me 3 letters, you're not naming an angle. So A, B, D. We just did this one, like right in here. That angle right there. That's the one we're talking about. Plus the measure of angle DBC is congruent to the measure of angle. Okay, so ABD, DBC, you just took the bigger one plus the smaller one equals the whole thing. So ABC. That's your angle addition postulate. You take one of them plus the other one, it makes the whole thing. Now let's see how that kind of relates to a proof. So this proof, work, reasons. Number one, we know that number 1 is always the given. The given here is that the measure of angle RAN equals 111 degrees. Okay, and then we've got RAN. Now there is something missing from our picture here. We're actually missing a letter here, so for the sake of argument, I'm going to add on the letter B. Now we have to prove that X is 62, and the only thing we're given is this and the diagram. So I'm going to look at this and I'm going to say, okay, well, if I'm going to use the angle addition postulate, the angle addition postulate, to be clear, tells me a whole bunch about the angles and the letters. It doesn't tell me about the x's. And if you're confused, this is x degrees, okay? This is 2x minus 75 degrees. It's not like a exponent of 0. It's degrees because we're talking about an angle. So step 2, I'm going to say if I take the measure of angle RAB and I add it to the measure of angle BAN, then that is going to be equal or congruent to the measure of angle RAN. And that is because of the segment, or sorry, not segment, angle. We're talking about angles here. Angle addition postulate, which we have right there. Okay, now moving on. Step 3. I know that if I take this angle and I add it to this angle, I get the whole angle. Well, what is this angle RAB? Well, it's being represented by x degrees, which I'm going to leave off the degrees. I'm just going to put x. Plus this angle, 2x minus 75, is equal to the whole thing, RAN, which if you go back up here, is 111. That is substitution. And then from there, we have to figure out how to prove that x is 62. So if we need to, scratch work over on the side. So we have x plus 2x minus 75 equals 111. The first thing I'm going to do is I'm going to take the x, add it to the 2x, which gets me 3x minus 75 equals 111. Now, once again, that is not addition because they were on the same side of the equation. So if they're on the same side of the equation, that is simply combine like terms. And when we did that, we got 3x minus 75 equals 111. So next thing we're going to do, I'm going to add 75. So we're going to take 111 plus 75, which is 186. So step 5, 3x equals 186. And why are we allowed to do that? That was addition property of equality because we added. Step 6, I'm going to divide by 3, which gets me 62. Okay, so if I go back, I divided by 3, so that's the division property of equality. And my variable has been solved for, so I go back and check. Prove that x equals 62. We did that, so we're done.